Okay, we're going to work through homework problem 455. We have a couple things going on here. So we have this A shape that we're lifting, and it's we're lifting that with a force here, 80 pounds. We also have the normal X, Y, Z axis, and then we're also rotating about that to this X prime. So X prime is here, and Y prime is here, and that's 30 degrees different than our this here called out is a 30-degree rotation about that. So that's probably where you might be running into some trouble with this problem. So our plan here, we'll find a step one, we'll find a unit vector for the x direction. Oh, that got a little sloppy. In terms of x prime and y prime. 2, we will find our position vector. So we're looking about this over the x-axis. So we can find a position vector from RAC, from RA to RC. So there we are. And then finally, we'll find the triple product of UX dotted with RAB crossed with F. So that's our plan. And that will give us our moment. So number 1, we'll find a position vector. So step 1, U of X. So we're looking here in terms of X prime and Y prime. We have this component. It's going to be in the X prime direction. So we're going to have that be cosine of 30. And we'll call that I prime. So the X prime direction. Plus, then we'll have the sine of 30 in J prime component. So the other part that's in this direction, so we'll come along this way some way, and then we'll come this way some way, and that will get us a unit vector in the x direction in terms of I and J prime. So that's maybe the unintuitive part. Hopefully that makes a little more sense. So we're adding this component here, plus there's a little bit more from this section here, right? So we're coming some direction there, and based on y prime, coming some in the x direction based on x prime. Add those two together, and we get our unit vector in x. All right, so we got that part taken care of. Now, step 2, we're going to find a position vector. RAB. So for A, we're keeping this in terms of I prime and J prime. So at point A, we have 0, 0, 0. C, we have in the x direction, we're going to have x prime direction, excuse me. We're going to have 6, right? So this length is 6 cosine 15. So we have RAB equals 6, or negative 6, excuse me, cosine 15 degrees. We're coming up a little bit, so we're losing not all of that length there. In the y direction, y prime, point C is here right in the middle, so we have the 6 feet that we can take in half, so we'll have 3, then we'll have that same cosine of 15 on top of that. Actually, that's going to be in the same place, right, because we're not losing any y position or y prime position with that rotation. So we're going to have plus 3, I should put I prime here, and J prime here, and then in the k direction, we'll have 6 sine of 15 k, and that's not prime because we haven't rotated the about x or y to change our z direction. So here's our position component there. So that hopefully makes some sense as well. And then finally, we'll do our triple product. So let me scroll down a little bit. We're not too far off here. I'll probably squeeze a little more in. So step 3, triple product. So if you recall from class, we said that the moment equal, instead of I, j, and k up here, we'll have the components of our unit vector. So we'll have cosine 30i plus sine, oh, no plus sign, let me get rid of that. Sine 30, 0. And then our position vector, so we'll take this component, this component, this component, put that in there. So we'll have -6 cosine 15 plus 6 sine 15. We're going to have 0 in the, oh, sorry. I wrote my k component in the wrong place. So we'll have 3 here, and then we'll have 6 sine 15 there. And then for our force vector, we only are lifting straight up, so we're going to have 0 in I, 0 in j, and then 80 pounds in k. And for convenience, I'll change this over to decimal numbers here, a little more straightforward. So cosine of 30, you may recall, you may not, you don't have to, 0.866. Sine of 30, you may recall that one, 1/2 or 0.5. 0 is pretty easy. 6 times the cosine of 15, it's -5.7996. 3 is just 3. 6 sine 15 is going to be pretty small, so it's going to be 1.553. And last row, 0, 0, 80. Then I'll copy my first column over again, 0.866, -5.7996, and then 0. All right. So we're going to have this times this minus this. So I'm going to have 0.866 times 3 times 80. I'm going to put in a bracket here. Minus 1.553 times 0. So I went this direction, then I changed signs and went that direction. Plus 0.5 times what we have here. So I added my extra row here, so I'm going to have 1.553 times 0 minus -5.7996 times 80. And then in my last direction, I have these two zeros here. So if I have, and I'm multiplying by 0, so I'm just going to write that as plus 0. All three products there are going to be 0. So we'll finish doing that math here, and we'll find out what we've got. So m equals that. M equals 0.866 times 240 plus 0.5 times this becomes 0, and then we're going to have, what is that on that side? We have going to be something like 460 something. Pull up my calculator quick. 5.7996 times 80. So that's times 463.96. So that's a negative, makes a positive, plus 0. I'm going to multiply by 0.5 and then add 0.866 times 240 to that. So we have m equals 439.82 Newton meters. M equals 440 Newton meters. That's our answer to 3 significant figures.